Hi everybody, this is Mr. Corzine. I thought I would do a quick video with you guys to help you through section 2.1. That would be the real number system, trying to figure out how to classify numbers. So these are your notes for 2.1. I'm sorry I couldn't be there today. I'll probably check in with you at some point, but make sure you get these notes done so that we can practice some more tomorrow and you can complete some of your homework tonight. All right, so one of the big things in this section is we have to be able to classify numbers. So if I look down here at my learning goal, I can analyze relationships among numbers. I can classify and compare numbers in the real number system. When I classify, I put them into a class or a category. That's what we mean by classify. You've probably talked about that in science. So for us, that means talking about the real number system, real numbers. You might be surprised to learn that there are actually imaginary numbers out there. We're not going to talk about those, but we'll talk about the real number system, and they have these different categories. It starts with the two big groups are rational, and over here are irrational. Starting to run out of room. And then it gets more and more specific. All of the rational numbers fit in this box, but only some of them fit in as integers, whole numbers, and then natural numbers. We'll talk about that more on the following page. But basically, this is what's going on. Now, I know there are some other instructions here. I want you to follow along with me, and you'll fill out your handout and your notes according to what I'm doing here on the video. Okay, so let's go on to the next slide. You are eventually going to take all of these numbers and place them into this graphic organizer right here. Now, I think you can probably tell this looks very much like the one we were just looking at on the previous page. So let me talk you through what rational and irrational looks like. So the big categories are rational and irrational. Most of the numbers we deal with are rational numbers. The irrational ones, if I could give you a few examples, they would be like, well, here's one, pi. Pi, this is 3.14159, something like that. Anyway, it has no end to it, and it never repeats. So that's something to keep in mind as we keep going through this classification. If you have a number that doesn't end but also doesn't repeat, that doesn't work. However, what you can have is you can have a number that doesn't end, it just has to repeat. Like for example, the number 1/3, I'll change over here. That can be rational. It is written like this, and it has the bar notation over the top. That goes on forever, but it repeats. So that's a big key for us as we try and make sense out of it. Okay. Now, as I talk about rational numbers over here, I'm going to skip back over here. Rational numbers start out very specific. They start out as natural numbers, or we also call them counting numbers. That's 1, 2, 3, 4, and so on. I like to think of these numbers as the cool numbers. Okay, everybody knows them, everybody loves them. It's what you learned in Sesame Street. This is a very exclusive group right here. They get to go to all the rational number parties, but they sometimes have their own like really exclusive ones right here, and that's the natural number party. This goes on up forever, but it's only the whole number starting with 1. Now they get a little bit more inclusive when they say, okay, we're going to be in this whole number group. Now the whole number group is not much different, only they include 0 this time. 0, 1, 2, so on. For some reason, poor 0, even though it's super popular, it's probably the most used number in the universe. It gets left out, and I think poor zero feels bad. I mean, it already is worth nothing, which is really sad. You know, can you imagine talking with zero and he's saying, "Oh, I just feel like I'm worthless," and you're saying, "Well, you know, you are zero. Like that's kind of your job." Anyway, that's a different story. But the natural numbers is a category, and then the whole numbers, that's a slightly bigger category because it includes zero. And then we move on to the integers. Integers. Integers are the same thing, only now they include some of the rebels. We've got 0, 1, 2, and 3, but we also have all of the negative versions, -1, -2, -3. So all those kids, they're all those numbers that are like, they're still cool, but they're kind of like counter cool. They're kind of like rebels, you know, and so they get to be a part of this integers group. Okay, keep in mind, anybody who's in the natural numbers group can go to the integers party. Anybody who's in the whole numbers group can go to the integers party. But anybody outside of here in this just general spot can't go into these specific parties. Now, finally, we get to just the outside portion where it's all just the regular old rational numbers. I think of those rational numbers, if I was a number, I would just be a regular old rational number. Like, let's say 4.2. Okay, that's a rational, regular number. It's got a decimal, though. Okay, you also have numbers like 1/4. It's a fraction. You got 58.7. Hey, it's rational. It just doesn't fit into any of these other categories. The real secret here is that any rational numbers can be written as a fraction. Okay, can be written as a fraction. Even a whole number like 3 can be written as a fraction. Another thing to watch out for are these radicals, these square roots. Now, I think you guys already understand that the square root of, say, 9, well, that's going to be 3, right? That one would actually fit all the way in here into our natural numbers, right? It would fit. Here's another one. Let's try the square root of 16, or the square root of 25, or the square root of 49, or the square root of 100. You guys know all of those. And actually, all of these end up being whole numbers. 4, 5, 7, 10. And so this whole group right here, even though they look kind of funny, they would be in here in this really exclusive crowd. Now, I bring this up because on the other side, here in the irrational zone, that's another specific type of number that will be irrational. If I have a square root of, say, let's say we're not going to do 25. Let's say it's 26. Ugh. That number is going to be pretty crazy. When I try and find an answer for that one, this is going to be like 5.1 something 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 something. It goes on and on forever, and we actually never arrive at a good stopping point. So it's really strange. Actually, I think it's 0.0 something. I don't know. Anyway, the next one. Let's try another example. How about the square root of 42? Square root of 42 is irrational because it's not a perfect square. We're not finding the square root of a perfect square. Another one would be square root of 17 or something. All of the numbers that are in between these perfect squares, they will be irrational. Now, we're going to talk more about those as we go, but I wanted to help you fill in your box a little bit. And now you should be a little bit more prepared to see if you could find the square root of any of these. Okay, finding the square root of any of these. All right, think you can handle that? If you can, go back, work on that. If you need a little bit more assistance, or if you get stuck on some of them, then turn the video back on and we'll do the next set of instructions.